In this video, we'll talk about how to evaluate inverse trigonometric functions. So when we're talking about inverse trig functions, there are three facts that are really important to remember. The first is that the inverse sine range, or sometimes this is called the arcsine range, is between negative pi over 2 and pi over 2. So we restrict the range to negative pi over 2 and pi over 2 when we're talking about inverse sine. So if we imagine our unit circle, when we say the inverse sine of a value, we're only letting ourselves look at the range from pi over 2 all the way down here to negative pi over 2. So this is the only range that we're looking at when we're talking about the inverse sine. Now, when we talk about inverse cosine or arc cosine, the range is from 0 to pi. So we're talking about from 0 all the way to pi over here. This is the only valid range that we're allowed to look at when we're talking about the inverse cosine of a value. And lastly, the inverse tangent range is also from negative pi over 2 to positive pi over 2, so just like sine. So knowing these facts, let's work through a few examples. Let's say that we want to find the inverse sine of 1/2. So this looks a little bit intimidating, but really all it's saying is when we want to find the inverse sine of 1/2, we're just asking ourselves what angle on the unit circle has a sine value of 1/2. That's all we're trying to figure out. What angle on the unit circle has a sine value of 1/2? Well, if you have memorized some of your important angles on the unit circle, you'll know that pi over 6 has the following coordinates: square root of 3 over 2 and 1/2. Now remember, the x-coordinate, this corresponds to cosine, while the y-coordinate corresponds to sine. So pi over 6 does have a sine value of 1/2. So that will be our answer. And remember, we're only considering angles that are within this range of negative pi over 2 to pi over 2. So for example, if this popped into your head, negative pi over 6, the xy coordinates that correspond to that are square root of 3 over 2 and negative 1/2. So remember, we're looking for what angle has a sine value of 1/2. So the only angle in this range on the unit circle that had a sine value of 1/2 is pi over 6. All right, let's try another one. Let's say we want to find the inverse sine of negative 1/2. So remember, all we're doing is we're asking ourselves what angle on the unit circle has a sine value of negative 1/2. And remember, when we're talking about inverse sine, the range that we're looking at, that we've restricted ourselves to, is negative pi over 2 to positive pi over 2. So what angle in this region has a sine value of negative 1/2? Well, if you think of a negative pi over 6, what are the xy coordinates for that angle? That would be square root 3 over 2 and negative 1/2. And we said the x-coordinate corresponds to cosine, while the y-coordinate corresponds to sine. So it turns out that negative pi over 6 does have a sine value of negative 1/2. So this answer will be negative pi over 6. This is the only angle in this restricted region that has a sine value of negative 1/2. All right, let's try another one. Let's find the inverse cosine of square root 3 over 2. So remember, we're really asking ourselves what angle on the unit circle has a cosine value of square root 3 over 2. And remember, for inverse cosine, we're restricting our range from 0 all the way to pi. So this is the only range that we're allowed to consider when we're trying to think what angle has a cosine value of square root 3 over 2. Well, if 5 pi over 6 jumped into your mind, think about the xy coordinates for that. That would be negative root 3 over 2 and 1/2. So remember, the cosine corresponds to the x value. So negative square root 3 over 2. So that doesn't work because we're looking for a positive square root 3 over 2. Well, what about the angle pi pi over 6. The xy coordinates for that are square root 3 over 2 and 1/2. So the cosine is the x coordinate and the y coordinate corresponds to sine. So it looks like the cosine of pi over 6 is indeed the square root 3 over 2. So that's our answer, pi over 6. This is the only angle in our restricted range of 0 to pi that has a cosine value of square root 3 over 2. All right, let's try another one. Let's say we want to find the inverse cosine of 0. So remember, we're asking ourselves, what angle on the unit circle has a cosine value of 0? And we're only allowed to look at the range of 0 to pi. So we're only allowed to consider this restricted range when we're thinking of what angle has a cosine of 0. Well, it turns out that the angle pi over 2, if you'll recall, the coordinates for that are 0, 1. So 0 corresponds to cosine, while 1 corresponds to sine. So pi over 2 has a cosine value of 0. So our answer is just pi over 2. This is the only angle in this restricted region that has a cosine value of 0. All right, let's try another one. Let's find the inverse tangent of -1. So we're asking ourselves, what angle on the unit circle has a tangent value of -1? Well, let's check out our inverse tangent range. It says it ranges from negative pi over 2 to pi over 2. So this is our restricted range. This is the only range that we're allowed to consider what angle has a tangent value of -1. Well, if you think of the angle pi over 4, what are the xy coordinates for that angle? That's square root of 2 over 2 and square root of 2 over 2. So if you recall, tangent is equal to sine over cosine. And we said the x coordinate corresponds to cosine, while the y coordinate corresponds to sine. So the tangent of pi over 4 would be root 2 over 2 divided by root 2 over 2. So the numerator and the denominator are the exact same number, so this whole thing would simplify to 1. So that doesn't work because the tangent of pi over 4 is 1, but we're looking for -1. So what if we try negative pi over 4? Well, the xy coordinates on that would be square root 2 over 2, the x value is positive, and negative square root 2 over 2, the x value is negative. So if we did the tangent of this angle, we would get, let's write sine over cosine, we would get negative root 2 over 2 divided by root 2 over 2. So these root 2 over 2's would cancel out since they're the same number, and we would just be left with a -1. And that's what we're looking for. So the angle negative pi over 4 has a tangent value of -1. So that's our answer. All right, let's try one last example. Let's say we want to find the inverse tangent of the square root of 3. So remember, all we're asking ourselves is what value on the unit circle has a tangent of square root of 3. And remember, when we're talking about the inverse tangent, we're restricting ourselves to the range of negative pi over 2 to positive pi over 2. So this is the only range that we're allowed to consider when talking about inverse tangent. Well, if we think about pi over 3, what are the xy coordinates for that point? That would be 1/2 and square root of 3 over 2, where 1/2 corresponds to the cosine and root 3 over 2 corresponds to sine. So we said that tangent is sine over cosine. So let's see if we can plug in these values and see what we get. So sine is square root of 3 over 2 divided by the cosine, which is 1/2. So remember, when we have a fraction divided by another fraction, that's the same as multiplying by the reciprocal. So instead of dividing by 1/2, we can multiply by 2 over 1. And when we do that, these 2's will cancel out, and we'll be left with root 3 over 1, or just root 3. So that is the answer that we're looking for. So pi over 3 has a tangent value of square root of 3. So pi over 3 is our final answer.